mistake in this. So it is uniform acceleration. So when you have uniform acceleration, so it is categorized into two. One we call it as a rectilinear motion. The other one is a curvilinear motion. Right. So rectilinear motion is when you have a movement. So when you have an object which is moving in a straight path, then we call that as a rectilinear motion. The curvilinear motion is it is like in a curved path. Okay, so something turning on a road, something like that. So we call it as a curvilinear motion, right? So today we will discuss about this rectilinear motion and what are the formulas related to that. So let me consider here. So I have mentioned two different types of motion in rectilinear. One we call it as linear motion, which is a straight path. The other one we call it as a angular motion. So angular is different from curvilinear. So linear means it is straight. Angular means it is rotating with respect to a particular axis. So particular axis, right? That is angular. So curvilinear, it doesn't have any axis. So that is different. So this is curvilinear, right? So angular motion is different from curvilinear motion. Okay. So if I consider what is the definition of a displacement, so usually you call S as a displacement in meter, right? Whereas if you go for an angular motion, we call theta in degrees, in degrees. Next, when you go for your uh, velocity, so u is the initial velocity. Whenever we call it as u as the initial velocity in meter per second. Whereas in angular motion, we will call it as omega naught. So omega zero or something like that, which is angular velocity, right? So it will be in radians per second. Okay. Similarly, final velocity, capital, so it is v. So u is initial, v is final velocity. This is also meter per second, and this is also radians per second, right? So if I go for acceleration, we call as a. So the unit is meter per second square, right? Whereas for angular motion, so we call it angular acceleration as alpha, which is radians per second square, right? Time, both are same, so both are seconds, right? And if we want to identify what is the velocity, so velocity, we know the expression. So velocity is differentiation with respect to time of your displacement, right? So we call it as ds by dt, right? Similarly, so if I want angular velocity, it is d theta by dt. So the only thing is your displacement here is changed to theta, right? Similarly, the same thing is also apply for your acceleration. So which is acceleration is dv by dt or d square s by dt square. So which will be called as d square theta by dt square, right? So next, if I go for your uniform acceleration, so you have a sets of formula, right, which you have to remember. So you'll be using this formula only based on this types, right? So the formula is v is equal to u plus at. So v square is equal to u square plus 2as, and s is equal to ut plus half at square. So these are the three formulas. So related to linear motion. So when you have an angular motion, so we know, so we are replacing your velocity in terms of angular velocity and acceleration as alpha, right? So same formula, you can able to see that only in terms of omega, omega naught, and alpha, so, right? So these terms are changed, but there is no difference in the formula, right? So we can apply it. So either it's a angular motion or a linear motion. The formula is same, only the notation is changing with respect to the particular values, whatever we are going to consider, right? So note that, so you have to use these formulas based on the questions which is asked. So how the questions are asked accordingly, right? So you can able to see here, we have v, u, a, and t. So usually we have how many terms? So five terms, right? So we have five terms. So which is s, u, velocity is two velocities, and acceleration and time. So you have five terms, right? So when you look here, you can able to see that you have four terms. So one is missing. So s is not there. So s is not here in this. So you know that. So whenever the data you don't have yes data, you can directly use this formula, right? Provided you should have other four datas, right? Similarly, when you consider this one, this one t is not there. So again, you have four datas: u, v, a, and s, but t is not available, right? So this is applicable. So whenever the time is not given, right? And the last one, so when v is not given, right? So v is not given. So the other four datas you can have, right? So you see that. So in all these three formulas, u is a common term, right? So u is a common term which is applicable in all the three datas. Similarly, a is also a common term, right? These two terms are common in all the three formulas, right? So it means that, so whenever they are asking you to identify u or a, you can use any of the formula to identify that value. And other than this, there may be some values of u, so they will provide values of u or some other data. So it may be, they may say it is at rest. When you say it is at rest, which means your initial velocity is zero, because from zero only it is starting, right? So something like that. So you can implement, so you can identify these values, any of these values, based on the data which is available in the question, right? So the last one, you have a displacement. So when you consider the displacement in nth second, for example, I want what is the displacement at a particular location, right? At a particular location at a particular time, right? Then we can use this. So u is equal to a by 2, 2n minus 1. Similarly, that can also be applied for your angular motion, right? But anyway, so we are not going to use these terms more. So we'll be using only these things. So we'll be solving lots of problems related to this. Okay, these are the things you would have studied in your previous 11th standard or 12th standard. So I'm just recalling it. That's it. Let us consider. So I am going to deal with motion, right? When I deal with linear motion, so I say that my object, whatever the object it is moving horizontally, right? Movement is horizontal, right? If the movement is horizontal, we have the three formulas. What are the three formulas? V is equal to u plus at. V square is equal to u square plus 2as, and s is equal to ut plus half at square. So these are the three formulas. We will be using it when your object is moving horizontally, right? So at the same time, so what happens? Let me consider, you have an object here and you are throwing it upward vertically. So you are throwing it upward, right? So this is towards top, right? So now you can able to see that your formula changes accordingly, right? So whenever I say yes, yes means the distance. This means the distance which is traveled. Here, the yes, it is not horizontal, it is vertical, right? So vertical. So we will call that as H. In some book, they will call it as H, as a different term. Okay. So I'm not going to confuse you. Let me consider yes itself, right? So I'm just reminding you that in some books, there will be a sets of formulas which is similar to that, relating yes as H, changing your yes as H, right? But no need. So whatever it is, yes is a displacement. It may be vertical or horizontal or inclined, whatever it is. Let us consider that as yes, as a single term to avoid confusions, right? But what happens here is your ball is moving upward, which is against the gravity, right? It is against the gravity. So which means my acceleration here is minus 9.81, right? We know what is the acceleration due to gravity. So that is your acceleration here, right? So my formula will change accordingly then. So what happens to my formula? My formula will be v is equal to u minus 9.81t, and v square is equal to u square minus 2 into 9.81. So 2 into 9.81. Yes. So they will call it as H here. So I'm calling it as S itself. Don't need to get confused. Similarly, S is equal to UT minus. So 9.81 divided by 2 T square. Right. This is be my set of formula. Right. So this is applicable when you're throwing upward. Right. When you're throwing an object upward. So, but what happens if I am throwing my object downward? Right, it is towards the gravity, so it is not against the gravity. So what happens, your a
Instead of minus, we should
is
add plus,
plus
no, sir.
9.8. Sorry.
Instead of minus, we should add plus, no, sir.
Yeah, instead of minus you will be considering plus, that's it. So the same formula, we'll be using the same formula, right? Only difference is that will be plus, so everything is plus now, right? So these are the sets of formulas, right? Usually we'll be using it for any type of problems when you solve, right? Okay, let us go for the problems one by one. We have a taxi driver who is traveling at 54 kilometer per hour, right? And she observes that traffic light of 240 meter ahead turns red. Okay, the traffic light is timed to stay red for 24 seconds. If the driver wishes to pass the light without stopping, so without stopping the car, just as it turns green again. So determine the uniform deceleration and the speed of the car when it passes the light. I have to identify what is my velocity, right? Make sure. So what is my initial velocity here now? So according to this
It
problem.
is 54, sir.
So according to this problem, my initial velocity u is 54 kilometer per hour, right? Make sure whenever you have in kilometer per hour, you change it to meter per second because everything we are solving in meter per second. So I am going to change it. So u is equal to 54. Kilometer to meter is 1000. Hour to second. So it is 60 into 60, which is 36 hundred. Okay. So what will be the value of your u? 15
15
meter
meters.
per second. Right. So now I got what is the value of u. So u is 15 meter per second. Okay, good. So now you know what is the distance, right? So you have a distance of 240 meter. So let me consider s is equal to 240, right? So next, so you know that what is the time taken for that 240? So 240 it takes 24 seconds. So I know the time also. So time is 24 seconds, right? So those are the things. So what are the things you are going to identify here? So they're asking what is your acceleration, which we call it as deceleration because we are when you get a negative acceleration, we call it as deceleration, right? Next, speed. Speed is your final velocity. These are the two data they are asking. Now, as we discussed, we have the three formulas, right? So what are the formulas? So v is equal to u plus at. So v square is equal to u square plus 2as, and s is equal to ut plus at of at square. So now for this three values which is given, which formula I can apply?
S is equal to ut
One,
plus half at square.
Third
yeah.
one, sir.
So third one you can apply. Very good. So you can able to see that you have u value, you have t value, and you have s value. So all these values, three values are known, only one unknown data. So you can easily identify what is the value of a, right? So which means directly I can use s is equal to ut plus of at square, right? So I will write it again. So s is equal to ut plus of at square. So s is 240. U initial velocity is 15 and the time is 24 seconds plus half into acceleration a, which I don't know, into your time is 24 seconds, so 24 square, right? So now I can able to identify what is my A. So A will be 240 minus 15 into 24 into 2 divided by 24 square minus 0.416 meter per second square. So that's why we call this as a deceleration, right? Very good. So now we identify the first data. So this is over. So the next one is speed. They are asking speed now, right? Speed is related to your velocity, final velocity. So I can use the first equation, right? So first equation, we know that. So V is equal to U plus AT, right? So velocity T is equal to U is known data, which is 15
15. 15, sir.
minus 0.416 into T. So T is your time. So time is around 24 seconds. So what is your V?
24.84 meter per second, sir.
24.84 meter per
Meters per
second.
second.
So your sprinter in 100-meter race. So accelerates for first 35 meter and then runs at a constant velocity, right? If the sprinter time for the first 35-meter is 5.4 seconds, determine its acceleration, its final velocity, and time for the race, right? So now you can able to see this problem. It is like there are two sets of datas, right? So you have to be very careful in this. The thing is, so if there is any change, you have to split that data accordingly, right? So if I draw a graph for this, for example, so let me consider this is my axis, right? This is my axis with respect to that. So I'm going to consider, sorry, I'm plotting velocity, right? I'm plotting velocity with respect to time. Okay, not acceleration. Acceleration will be different, right? You have a constant increase in velocity, right? For first 35 meter. After that, your velocity is constant, right? It is straight. Okay. So in that case, what I have to do is I have to split into two. So the first part up to 35 and second part after that, right? Because they are asking the data with respect to that. So we will do that accordingly. So for 35, right? For first 35 meter, what are the data available, right? You know, yes, yes is known, yes is 35, which
Initial
is known.
velocity is 0.
So yeah, initial velocity is zero. So initially is starting it, so it is zero.
T is known, sir.
Time taken is equal to
Time taken is
5.4 seconds.
5.4 seconds, sir.
So yeah, time is given, which is t is equal to 5.4. Say, I'm not writing the unit here because this yes and this yes will get confused. These are the datas. So I have that four formulas, three formulas. Which one I can apply?
S is equal
So
to
we have
UT plus half AT square.
same formula, right? So same
Yes, sir.
formula we can apply because we know all the data related to that. So what I can do, I can use S is equal to
UT
UT
plus half a T square.
plus half AT square, right? So yes, you know, which is 35, U is 0 plus half A, T is 5.4. So the whole square, right? So what is the acceleration?
Sir, 2.4, sir.
So you're getting 2.4 meter per second square. Very good. So my acceleration I got, it is 2.4 meter per second square, right? So that is the first step. So determine this acceleration. After that, your acceleration is zero. So this is my term which is related to the 35 meter. Okay. Then they're asking what is the final velocity and time. What is the final velocity and time, right? So velocity final, I think it is also same. So if I apply it because it is a constant velocity, right? So So now to identify this velocity, what I can use v is equal to u plus at, right? So which means v is equal to u is 0, a is 2.4, right? But they are asking final velocity, right? So okay, right? So final velocity. So I think this is the velocity for the 35 meter. Okay, so I have identified what is my values. So 5.4. What is the velocity you are getting?
96.
12.96. Okay, 96 meter per second. Okay. Uh, hope this will be the velocity till that 500. Sorry, till that 100 meter, right? So now let us identify what happens for 100 meter. Right? What are the data we got? Right. So if I consider 100 meter, so I'm going to start. This is my initial velocity now. So u, which is final velocity of first term, right? Which is final velocity of first term. So which means your u is 12.96 meter per second. So it is constant. So your v will also be same, 12.96 meter per second, right? And so I was asking what is the time taken, right? What is the time taken? So for this constant movement, right? So let us identify what is the time taken for this, right? So what I can do, I will identify s is equal to ut plus half at square, right? So this is the formula I'm going to apply. Now, what will be the value of this s?
Zero,
Can
sir.
you
65,
guess?
sir.
Yeah, very good. So it is 100 minus
Minus
35.
35, 65.
So totally you will get 65,
65.
right? So because we are considering the second term part alone, so we have to consider only that. So which means, so 65 is equal to initial velocity is 12.96 into t, right?
Plus
Plus half into what is the acceleration for this
0,
particular
sir.
condition?
0.
Zero. Very
zero,
good.
sir.
So your acceleration is zero, right? Which means this entire terms gets cancelled, right? So only thing is I can identify what is the value of t. What is the value of t? So 65 divided by
So by
12.96.
110, so
5.015 seconds, sir.
So 5.015 seconds. So let me call this as T1. So T2. So for the second case, and T1, you know that. So T1 is this one is T1 because for first case, right? For first case, for first 35, you are getting 5.4. So the next 65, you are getting 5.06. So total time taken, right? So total time is 5 point, I think it is 5.4.
Sir, 10.415.
So 5.015. So what is the total time?
10.415.
10.415. Yeah, 415 seconds. Any doubt on this? So let me consider here. Relay runner A enters a 20 meter long exchange zone. So at that time only they are going to exchange that pattern, right? So with a speed of 12.9 meter per second, he begins to slow down, right? He hands the baton to runner at 1.82 seconds later. As they leave the exchange zone so once they leave the exchange zone, the time taken was 1.82, right? With the same velocity. So which means the velocity of A and B both are same when they leave this 20 meter. Okay. So determine the uniform acceleration for each runners when runner B when runner B should begin to run, right? So these are the two data they are asking. Now, so we will again, so it is also considering there are two different datas. So one for runner A, other one for runner B. So we have to do that separately. So first, let me consider about runner A. So let us identify what are the datas related to that. So runner A, you have initial velocity. So initial velocity is 12.9 meter per second. And s distance. So don't think about the entire distance. It is only when it is passing, which means s is equal to 20. So that is the value of your s. Okay. And when he gives that particular, so when he crosses 20, so when he starts here, your velocity is initial velocity is 12.9. So at 1.82 seconds, at 1.82 seconds, he leaves the exchange, that is 20 meter, crossing 20. So the time t for this is 1.82 seconds, right? So I can identify what is my final velocity, and let us identify what are the other data related to this. Okay, so these three data again, right? It is related to u, s, and t. So my formula will be s is equal to ut plus half at square. Right? So let us apply what are the data available here. So S is 20, U is 12.9, and time is 1.82 plus half A I don't know. So this is 1.82 the whole square. Right? So can you identify what is the value of A? So A will be 20 minus 12.9 into 1.82 into 2 divided by 1.82 the whole square. What will be the value of A?
4.286, minus 2.099.
Minus 2.0.
99, sir, next. 2.099.
So 2.099. Okay, minus 2.009 meter per second square. Right, this is my acceleration. Right, so I think the first for runner A, I identify what is my acceleration. Right, this is my acceleration. Right, so now the thing is I have to identify what is the velocity. Right, what is the velocity? Because when both are leaving the zone, right, when both are leaving the zone, they are at the same velocity that is given. They're at same velocity. So let us identify what is the velocity for runner A, right? So we can use this formula. So V is equal to U plus AT, right? So V is equal to U is 12.9 minus 2.099 into time. What is the time? 1.82. So what is my V here?
9.079, sir.
9.079, okay, meter per second. Okay, so now let us go for the next runner. So I think we completed this runner A. We'll go for runner B. Consider runner B, your initial velocity is starting, so it is 0, and final velocity is achieving is 9.079 because when it leaves, right? And you know what is the distance? Distance is 20 meter, right? He should also travel for 20 meter, right? So that is your distance. Okay, so these are the datas. So what I have to identify is what will be the acceleration and what is the time. They are asking what is the acceleration and time. Okay, which formula we can use here?
V square is equal to U square minus 2AS.
So we can use v square is equal to u square plus 2as, right? So I have v, I have u, and I have s. So I can easily identify what is the value of a, right? Very good. So now let us substitute it. So this is 9.079 the whole square is equal to u is 0 plus 2 into a into 20. Right? What is the value of a? So a will be 9.079 the whole square divided by 40. So what is the value of a?
2.06.
So we are getting 2.06 meter per second square. Very good. So now we identified this value, a value we have identified. And you know what is the v value also. We have to identify what is the time taken. So when he has to start running, right? That is the other thing they are asking, right? So we can use any of the formula. V is equal to u plus at. So we'll apply in this formula. So v is 9.079. So 9.079. U is 0 plus acceleration is 2.06 and your time is what you are going to identify. What is the
4.4.
value of it? So 4 point.
407.
So you are getting
407.
4.407 seconds, right? So which means he has to take 4.40 seconds so to start, right? So when he is crossing this, right? When A is crossing at the location 20, when he is crossing this, the time taken for B should be 4.407. Any doubt in this?